All right, I'm going to look at a calculation involving modular arithmetic, and I'm going to do this two different ways. So the first approach I'm going to use is where we just basically look at what we're given, do the operations, and then do the modular arithmetic. And then the second part is we're going to use the theorem to try to simplify the operation and then do the multiplication, and then if we need to reevaluate this under the modulus, we will do it at that time. So the first approach, we're just going to look at 26 times 65, and then we're going to do this modulus 12. So 26 times 65 is a pretty big number. 1,690, and we need to evaluate this modulo 12. And so we're going to look at how many times 12 divides into 100 or 1,690. So we're looking at this, and so it'll go into 16 one time, and we just do the long division as normal. So 4 times 12 is 48. 12 won't go into 10. And so 10 is going to be what this is congruent to. So 1,690 mod 12 is going to be congruent to 10. So that's our first approach. All right, the second method is we're going to apply a theorem. We have a theorem that tells us that we can look at these individually, apply the modulus, and then multiply, and we will get the same result. So 26 mod 12, so how many times will 12 go into 26? Well, it'll go twice. 24 is as close as you can get. 26 minus 24 is 2. So this number is going to be congruent to 2. So we're looking at 26 mod 12 being congruent to 2. We also want to look at 65 mod 12 and determine what that is congruent to. So this is going to be congruent to 5. So now we're going to look at 2 times 5, because this is congruent to 2, this is congruent to 5. 2 times 5 is 10. 2 times 5 is 10. And 10 mod 12, we need to check this. Since this number is smaller than our modulus number, it's going to be congruent to the number we started with, so this is 10. 10 is our solution here. 10 was the original one that we got from method 1. So either way you do this, if you do the long drawn out multiplication and then do the modulus, or if you do the modulus of each individual term and then multiply, you will get the same result. It makes sense to use the theorem because it simplifies the arithmetic from the get-go. We look at 2 times 5, which is easy to calculate as 10, rather than 26 times 65, and then have to do the modulus on that. It's a lot longer process. Hopefully this is helpful. Cheerful calculations.